So today we're going to be looking at binomial expansion. So previously we've expanded things like 1 plus x squared, and that's pretty easy. That would be 1 plus 2x plus x squared. Now we're going to be looking at things of the form 1 plus x raised to some power n, where n can be any positive number. Now, binomial means two terms. The word bi means two. So anything that is of this term, of this form x plus 3 or 5x minus 2y would be binomial. It's got these two terms. Anything that's got these two terms is binomial. So we know that, so we've got a plus b to the power 2, that's a squared plus 2ab plus b squared. Now we can use this to find out what this would be, a plus b cubed. We can do a plus b times a squared plus 2ab plus b squared, and we get a cubed plus 2a squared b plus ab squared plus a squared b plus ab squared, oh, it's going to be plus, plus b cubed, which simplifies down to a cubed plus 3a squared b plus 3ab squared plus b cubed. Similarly, we can do a plus b to the power 4. If we work it all out, we get a to the power 4 plus 4a cubed times b plus 6a squared b squared plus 4a b cubed plus 4 to the power b to the power 4. Now, you could keep going with this. You could keep raising a plus b to the power 5 or a plus b to the power 6. But as you can see, this is quickly going to become really quite complicated. In GCSE, there were some questions where you had something similar to this that you had to, which you had to expand the brackets and simplify. And although the maths of it wasn't complicated, because you could very quickly run into bother when it came to simplifying it, because the expressions were quite long. So this is quite clunky. So we need to be looking for a way in which we can do this, which is more simple. So let's look at it and see if we can find any patterns. Well, let's look at the powers. So this is raised to the ends, in this case is 4. Look at the powers of a. 4, 3, 2, 1. Then we could have a to the power 0 here would be 1. So that's 0. Now look at the b powers. So b to the power 0 would be 1. So 0, 1, 2, 3, 4. So the powers on the terms, for the a term they go down by a power of 1, and then for the b term they climb by a power of 1. Now let's look at the and that's the same for all of these. Now let's look at the coefficients. We've got 1, 4, 6, 4, 1. Here we've got 1, 3, 3, 1. And for this one we've got 1, 2, 1. And what we see is that the coefficients follow a pattern known as Pascal's triangle. And this is something that you've probably come across and probably done little exercises on in the past. And it turns out that Pascal's triangle is actually a really powerful piece of maths with lots of different hidden sequences and patterns within it. So let's have a refresher memory as to what Pascal's triangle is. So say we start off with 1, and then we've got 1 and 1. Then we're going to add these together. So 1 add 1 is 2, and then we have our 1 and our 1. So it's like, we'll say 1 add 0 is always going to be 1, 1 add 2 is going to be 3, 2 add 1 is 3, 1 add, and there's nothing there, so that's 1. Again, you've got your 1, then you've got 1 add 3 is 4, 3 add 3 is 6, 3 add 1 is 4, and then we have our 1. Then we've got 1, 1 add 4 is 5, 4 add 6 is 10, again 10, 5, and 1. And we can do another 1, 1, 6, 15, 20, 15, 6, and 1. And you can see that these numbers are going to very quickly get quite big. And so we can correspond this to, this would be n is 0, this line, and we've got n equals 1, then n equals 2, then n equals 3, n equals 4, n equals 5, and n equals 6. So say we had a plus b to the power 5, well, we can then we can read off n is 5, we can read off the numbers here from Pascal's triangle, and it'll give us the coefficients. So here we have 1, a to the 5th, plus 5, a to the 4, b, plus 10, a cubed, b squared, plus 10, a squared, b cubed, plus 5, so 5, a, b to the power 4, then plus b to the power 5, 1 times b to the power 5. Now let's look at how this would work with some examples. Now I want to actually I'm going to rub out this here. So I want to keep Pascal's triangle up so that we can keep referring back to it when we're doing our examples. Okay, so let's do an example. We're going to do 3x plus 2 squared. So n, not squared, cubed. So our cubes, we're going to have 1 times, the a expression here is 3x. So we do our 3x, and that's going to be cubed. And this is going, and then b is going to be 2 to the power 0. So this is 1. So now we've got our next coefficient is going to be 3. And we're going to times 3x squared, and now we've got, and then we're going to times 2. And we've got another 3 coefficient, and this time it's 3x to the power 1, and now we're going to have 2 squared, and then we'll have 3x is going to go to the power 0, so that's just going to be 1, and we've got our coefficient of 1 here, and then we're going to have 2 raised to the power 3. Now what we have to do is go through and do all the maths. So 3 to the power 3 is going to be 27x cubed. 3 squared is 9, times 3 is 27, then you're going to have times that by 2, which is going to be 54x squared, then plus, so 2 to the base to 2 is 4, times 3, and we get 36x plus 8. Now we're going to do another one. We're going to do 5 minus 2x raised to the 4. So again, we go through the same process. We will have, so our coefficients for n to the 4, write them down here, are 1, 4, 6, 4, and 1. So we'll have 1 times 5 to the 4 plus 4 times 5 cubed. Now we've got minus 2x, then we've got plus 6, 5 squared minus 2x squared plus 4, and this is 5 to the power 1 plus, oh no, not plus, times minus 2 cubed, and then we've got plus 1 times minus 2 to the power 4. Now we work all this out, we're going to have 5 to the power 4 is going to be 625. Now this is going to be minus 1000x, then it will be minus 2 squared is going to be plus 4 times 25 times 6 is going to be plus 600x squared. Then we have another minus because it's minus 2 cubed, and then times 5 times 4, and that's going to give us minus 160x cubed, and then the final term will be positive 16x squared. And now we're going to use Pascal's triangle to work out 1 minus 2x to the power 5. So again, we look at n to the 5, and we will get 1 to the 5th, plus 5, 1 to the 4, minus 2x, plus 10, 1 cubed, minus 2x squared, plus 10, 1 squared, minus 2x cubed, plus 5, 1, minus 2x power 4, and I'll put this plus 1, minus 2x to the power 5. Working all that out, we get 1 minus 10x plus 40x squared minus 80x plus 80x, so it's cubed, x to the power 4 minus 32x to the power 5. Now, we want to find the coefficient of x cubed in 3 plus 5x 1 minus 2x to the power 5. So we're going to take our 3 plus 5x and then expand out using our binomial expansion that we've just done. Now here we've got to be really careful with our terms. Now we want to find on this term here, so we're going to be looking at when is this going to, so this will, when we multiply this term, and we'll find x to the power 3. And if we take 3 and multiply this term, we've got another x to the power 3. So we don't need to multiply the whole thing out. So the x cubed coefficients are going to give us minus 240 plus 200, and that is minus 40. So I hope that helps.